Phillips screwdriver, a great invention for putting screws in and taking screws out. It was invented in 1923 by an employee of the Ford Motor Company so that screws could be taken out easily. Well, the PH in Phillips stands for push hard, because you had to push hard to get that screw in. And it was better than the old screwdriver, but not as good as what we got today, right? So now we got our power screwdriver, a better tool for getting the job done. All right, there we go. So, the Phillips screwdriver is like our limit definition of the derivative. If we've got a function like y equals x squared, and we want to find the slope of the tangent line at any point, we can use the formal definition or the limit definition of the derivative. It works. We have to kind of press hard to get it done. We had to push through, but we can get it done. Great tool, that formal definition, but now we need a better tool to get it done. So we're going to look at some shortcuts so that we can find out that the derivative of this y equals x squared is 2x, so that we can quickly find derivatives and we can generalize things, and we can use derivatives for lots of important things in math and science. So let's get to it. We like shortcuts, so let's dig into it and see if we can find some patterns that can give us some shortcuts. All right, so we know that, as we just talked about, the derivative is the slope of the tangent line, also known as the instantaneous rate of change. So how quickly it's changing at a very moment. Lots of ways to write the derivative. Remember that all of these are the same: f prime of x, d dx of f of x, or y prime, or d dx times y, or dy dx here. Lots of ways to write this, and they all have some different purposes and work better in different ways. All right, so we have some specific rules here that we've kind of that we're going to explore. Some of them we've kind of discovered some things about. The constant rule. What if we have a constant? What if we have x to some power here? What if we have the derivative of sine? Whoops. And what if we have the derivative of cosine? So those are specific rules. Then we're going to have some general rules that talk about, well, what if we have a function that is multiplied by a constant here? What do we do with that constant? What if we have two functions being added, a sum of functions there? So those are general rules. All right, so important quick thing to clarify is that when we say dy dx, well, that's a noun, that's a thing. So dy dx is the derivative of y with respect to x. If we say d dx, that's a verb. It's kind of like an operator. It's saying take the derivative of that thing. So when we say d dx of this, that means we need to find the derivative of this function. Find the derivative of this. But if we say I have dy dx, that means this is the derivative. All right? So some notation things to get used to there. So the first thing we want to look at is, what if we have a constant like f of x equals 3? What's the derivative? Well, here's the graph of f of x equals 3. And if we pick any point here, the slope of that line there is, at that point, is 0, right? The slope at this point is 0. The slope at this point is 0. So it doesn't matter where you go, the slope is 0, and the slope is the derivative. So we have a rule. When we take the derivative of a constant, we get 0. All right? So that's our rule. Okay, easy. All right, let's get a little more challenging. What if we have a power? So x to some power, that's a power function. Well, we've done the limit definition, or the formal definition, and we've seen that the derivative of y equals x squared is dy dx equals 2x. But what if we have just a general x to the n? So we're going to investigate that, but we need to talk about the binomial theorem for a moment here. So we need the binomial theorem to do a proof here in a second, but I'm going to cut this part out and put it in a different video. So we're going to jump here now to talk about how the binomial theorem works. And so we're going to cut this out. If you want to watch where this binomial theorem, how it works, check the other video out. And the reason this is useful is these are the coefficients, all right? So these are the coefficients here of a plus b squared. That's going to be 1a squared, 2ab, 1b squared. And so this is squared, cubed, fourth power, fifth power, sixth power, seventh power. If we wanted to know the a plus b to the seventh, we're going to have this guy, a squared, actually a to the seventh, because we're talking 7, plus, and then it's just going to go down. The exponents on the a goes down and the b goes up. B to the first. Then we're going to have a to the fifth, b to the second. Then we're going to have a to the fourth, b cubed. Then we're going to have, moving on over, continue the pattern. You hopefully get the idea. The a's are going down, the b's are going up. A's are going down, b's are going up. And we'll get all of our terms, and so we can know exactly what it is. Now, this is, again, a great background, good to know, especially those of you that are going to continue on in math. Everyone else, just kind of breathe deep and say, wow, that's amazing. Let's see that if we can use that. Okay, the key is knowing that this exists, because let's go discover the rule for the derivative of x to the n. All right, here we go. Going to be a lot of algebra, but this is going to develop our power tool so that we don't have to do this anymore. So using the limit definition, here we go. The limit as h goes to 0, and I'm going to go kind of fast here, but if you want to pause the video and rewind, you might feel free to do that. So we want the limit of f of x plus h minus f of x all over h, right? So there's our limit definition. It's always nice to write that down first so we can remember where we're going. Now, let's go ahead, and the function itself is x to the n. Okay, so we're going to have, don't forget my limit as h goes to 0 of, and we have x plus h to the nth power minus x to the n all over h. Now, here's where all of that binomial theorem is going to come in. So we need to figure out, how do I do x plus h to the n? Well, n, what is n? Is n the second power, or the 7th power, or the 20th power? Well, n could be any power. Okay, so what do we do with that? Well, let's just think about what it looks like here. All right, I'm going to copy down this minus x to the n from over here. Okay, we got that. Now, notice that all of these, if I have x to the a plus b to the 7th, it starts with a to the 7th. If I have a plus b to the second, it starts with a squared, 1a squared. And the next one's going to be 1a cubed if we write it out, 1a to the 4th, 1a to the 5th, right? So no matter what the degree is there, we're going to start with the first thing to that power. And then we're going to end with the second thing to that power, right? So, and we're going to have a bunch of other products in between. So, that tells us that the first term will be x to the n. The second term, notice this, the second term in all of these, let's actually go up to these ones up top. Look at the second term. If we had the second degree, a plus b squared, we had the second term was a 2ab. The next one to the third power was a 3a squared b. Next one was a 4. Right here, 4a cubed b. The next one is a 5th, so on and so forth, right? So 5th degree, that coefficient is 5. So our next term is going to be not a coefficient of 1, 2, 3, or 5. It'll be a coefficient of n.
And then we'll have x to the n minus 1 times h to the first. All right? Now, the next terms there's going to be a whole bunch in here. I don't know what n is, so I don't know how many terms there will be. But I know that they will all have h to something bigger than 2. So h to something here, and this question mark will be bigger than 2. All right? So keep that in mind. Okay? And then we'll end up with this minus x to the n. And there will be, let's go ahead and throw, we know we're going to have at the last one will be a 1h to the n. So all of this stuff right here is going to kind of disappear, as we'll see in just a moment. So that's our fudge factor here. So here's what we have. The limit as h goes to 0. Well, these all cancel out here, right? X to the n cancels out with a minus x to the n. And that leaves us with nx to the n minus 1 times h plus all of this junk that has an h to the question mark that this is of order 2 or greater. Okay? Divided by h. Now, to simplify this, we have a bunch of terms here and a single term here. Remember that we divide h into all of these h terms here. Everything's going to get divided by h to the first. And that's going to leave us with limit as h goes to 0. And the first term will be nx to the n minus 1 plus, and then all of these, since they had at least h to the 2 or greater, will have h to the first or greater. Okay? So there are going to be a bunch of terms here that will be at least h to the first. Now the question is, what happens when h goes to infinity? I'm sorry, to 0. Well, when h goes to 0, these guys all go to 0. And they all go to 0, and that leaves us with this guy. This does not have an h term, so we have n times x to the n minus 1. So there you have it, and we have just proven that the derivative of x to the n is n times x to the n minus 1, and we never have to do that again. We've got our power tool, our first power tool. All right. So here's our tool. We have the power rule right here. It says if we have x to the n, all we do to find the derivative is we drop the n down and we write n minus 1 as our new power. And that will be the derivative, all right? Now the function must be differentiable, all right? And it must be a number so that we can actually take n minus 1, all right? So, all right. So what does that mean? That means this. We have x to the 5th. Well, we're going to take this 5, and we're going to drop it downstairs to take the derivative, and we're going to subtract 1, and we get 4. There it is. The derivative of x to the 5th is 5x to the 4th. Well, what if we have a x in the denominator? Well, let's rewrite this as a power. This is x to the negative 2nd. So the derivative of x is negative 7. Let's drop that down. We get negative 2x. And subtract 1. What's negative 2 minus 1? That's negative 3. Now, we always want to write our final answer with positive exponents in most cases. So let's take that negative exponent back downstairs. So we write it as an exponent and then use the power rule. So one more, d dx of the square root of x. Well, square root of x is x to the 1/2, right? So let's take that power. It drops down to take our derivative, 1/2 x, and 1/2 minus a half is negative a half. Sorry, 1/2 minus 1, right? So our rule, once again, is we're going to drop the exponent down. The exponent goes down in front, and we subtract 1 to get our new exponent. And so we want to write this as 1/2 times, well, x to the negative 1/2 is 1 over x to the 1/2. And we might actually want to write that as a square root just to make it a little prettier. This is 1 over 2 times the square root of x. And that's one you might want to memorize. The derivative of x squared, or the square root of x, d dx of the square root of x, is 1 over 2 squared root of x. That should go on a note card. All right, well, lots of stuff there. We'll probably pause the video there, and we'll pick the rest up on another video here. So great job. And we'll continue from there to find some more rules to make life a whole lot easier.